Okay, so we're going to look at all these different features, properties, characteristics, whatever you want to call them, for functions at each of the different graphs. So first we need to decide if the thing is a function. If it is not a function, then we can just move on. We don't have to do all those other parts of the question. So is part A a function? Well, when we look at a graph trying to decide whether or not it is a function, the simplest way to determine that is the vertical line test. So a vertical line passing across the graph never hits two or more points. Therefore, yes, this is a function. Is it continuous or discrete? Well, continuous means there are no jumps. So that is the case here. We have one motion. We could draw the entire graph without picking up our pencil. So this one is continuous. Is there an increasing interval? Again, we read left to right. So this side of the graph is increasing, the left-hand side. That's from -3 to 1. We always list intervals on the x-axis, not how low or how high it goes, but where did the increasing interval occur? And that was from -3 to 1. So increases from -3 to 1. And it is always up to you whether you use less than symbols or less than or equal on increasing and decreasing intervals. The decreasing side of the graph is this right-hand side. So that starts from +1 and decreases till we get to 4. So that's from 1 to 4. The maximum of the graph, the highest point on the graph, happens here with a value of 4. The minimum, the lowest it ever goes, is down to 0. So those are, max and min are y values. Increasing and decreasing are always given on the x-axis. All right, domain is the x's and range is the y's. So our domain from left to right, it starts at -3 and goes to 4. So our domain is from -3 to 4. We do have a point on -3. We do have a point on 4, so we need to include those. The range, bottomest to toppest, the bottom point is 0, which we already listed as our minimum, and our highest point is 4, which we gave as our maximum. So we're kind of using those again here to say from 0 to, now this one's f of x because we're doing range, from 0 to 4. And again, we do have a point on 0 and we do have a point on 4. X-intercept or seps, we can have any amount of x-intercepts. It's where does this graph hit the x-axis? Well, just once, and it's here at 4. And the y-intercept or seps is where does it hit the y-axis, which it only has one, and it's not exactly on a whole number. So it's, let's say it's approximately, I don't know, 3.1 or 3.2. Part B, same directions, but our first decision here about whether or not this is a function, when we take a vertical line through it, it hits 2 points at almost every point along the graph. So this thing is definitely not a function. So we're going to say, nope, not a function, and move on. We won't bother doing the rest of those questions. Okay. We got C and D here. So graph C, it does pass the vertical line test. I can demonstrate that real quick. When you pass over this graph with a vertical line, you will never cross over 2 or more points of that graph. Therefore, this is a function. So, yes. It is continuous because there are no jumps. It has increasing parts. Now, it has a couple of them. So let's look for these. The increasing parts of the graph are here till we top out and then another increasing part over here. So we may have to estimate exactly where those begin and end. Let's see, it starts increasing at -8 and continues increasing till we get to, oh, it's about -1/2, I guess. And then it increases again from 5 till 10. It decreases in between those, so it decreases here. That is from the -1/2. Whoops. We don't want to write with a highlighter. From -1/2 to 5. Our maximum, the highest this graph ever reaches, is to 5. It's out here. So the maximum is 5. The minimum, the lowest, down here, is at -3. Our domain, leftiest to rightiest, it goes from -8 to 10. So -8 to 10, including both points at -8 and points at 10. So include those endpoints. Range from bottomest to toppest. So from -3 to 5, and again, this is not a coincidence that our max and min are those same numbers. So -3 to 5, we do reach -3, we do reach 5. X-intercepts, there is just one. It happens at -6. Y-intercept, we have 1. And again, that one's not on an exact integer. So let's say it's about 4.2, 4.3, somewhere in there. For D, we want to do our vertical line test again to check for whether or not it's a function. I'm hitting only 1 point here, 1 point, 1 point, 1 point, and 1 point. So this function only has 5 individual points. Nothing's connected. So yes, this is a function. I cannot make 2 of those individual points lie on the green vertical line at any time. It is discrete. This is an example of a discrete function where you would just have to list each individual point. Increasing, well, we don't have any intervals, increasing, decreasing, or of any other kind, because nothing's connected. So none, none. You can't have an interval if you have a discrete function. Maximum would be the highest point, that's at 3. The minimum would be this lowest point. I'm going to say that's probably at 1/4. The scale here is counting by a half, so that looks halfway to a half. That's 1/4. The domain. Now, being that this is a discrete function, I cannot say that I have everything from the leftmost point to the rightmost point. I have just these specific points in the x as x values. So the first one is 1/2. Then I have a point with x value of 1. Then I have a point with an x value of 2, then 3, then 4. I have just those 5 values. Nothing in between, nothing before, nothing after, just those points. The range, I have to do the same kind of thing. I have a point at 1/4, at 1/2, at 1, 2, and 3. So 1/4, 1/2, 1, 2, 3. I don't have any intercepts at all because there are no points lying on the x-axis, no points lying on the y-axis. So I need to say none and none. Okay, graph E. Let's see if I can, whoops, if I can make this fit a little better here. Up, up, okay. So, vertical line test. if I move across this graph, will I ever hit 2? Whoop, yep, right there. So this one is not a function. Therefore, we don't have to answer any other parts of the question. Graph F. Again, we'll start with the vertical line test. So can I hit more than 1 point? Nowhere. Nowhere on that graph do I hit more than 1 point. So this is a function. It is increasing everywhere on the graph. Now, this is a little sloppy, I think. That line seems to go a little bit beyond the endpoint there at 3,8. I don't think it was meant to. So let's just make that a solid dot there. So this has endpoints at both the left and right side. So it is increasing over its entire domain, which is from -3 to +3. So from -3 to 3. It never decreases, so there is no decreasing interval. It has a maximum, a highest value up here at 8. It has a minimum or a lowest value at -10, of -10. Its domain, like we said about the increasing interval, is the entire graph. So from the leftiest point, -3, to its rightest of 3. -3 to 3. This time, though, it is important to decide whether or not the endpoints count. There is a point at -3 and there is a point at 3. They both should be included. Its range from lowest to highest is from -10 to 8. Again, like our max and min. So from -10, this is f of x, to 8. There is a point reaching down to -10, and there is a point up at 8. X-intercepts, yes, there is one. I can't tell you what that value is. It's right here. Let's say it's about, I don't know, 0.2, 0.3, maybe a quarter. Y-intercept is exactly on -1. Actually, I believe that x-intercept is about 1/3. So let me go back and change that. That's about 1/3. Y-intercept is -1. All right. Graph G, is this one a function? Now, this one, you got to look carefully. I'm not hitting 2 points. I'm not hitting 2 points. I'm not hitting 2 points. Am I hitting 2 points when I get to an x value, when I get to 6 on the x-axis? Now, I could definitely see, I'm having trouble moving my line, how somebody would say, yeah, I'm hitting 2 values here. But notice the point at 6, 7 is an open dot. What that means, just like on a number line when you're graphing inequalities, is that point doesn't actually count. That dot is hollow. So the point 6, 7 is not part of the graph. Now, the graph picks up right after that point, but 6, 7 is an open dot. It does not count. So if that's the only place that we hit 2 points, then this still can be considered a function. So let's try. Yep. Okay. So we never do hit 2 points of that graph at the same time. This is a function. Now, where is it increasing? Let's take a look here. It increases, no part of that. This increases till it tops out about here. Decreases, decreases. It starts increasing again here at the last little tail. So it has increasing parts from 6 to about 10. And also from 18 to 21. Okay, its decreasing parts are the other two connecting parts of the graph. Here it decreases, and here it's decreasing. So those are from the beginning, 0 to 6, and then again from 10 to 18. It has a maximum, a highest value of 10, and a minimum, a lowest value of -2. Its domain is everything from 0 to 21. Now, since this graph has a jump in it, making it discontinuous at that point, not a continuous overall function, do we say the domain is one interval from 0 to 21? Well, that would mean that we have to use every value, and the question would be here around 6. We do have a value of everything until we get to 6. Then it jumps up, and this one picks up. That's why we do the open circle and then start another connected continuous part of the graph. It picks up right after 6, so we skip over nothing. So every value, every x value from 0 to 21 does have a y value associated with it. So that means our domain is continuous interval from 0, including 0, to 21 and including 21. Our range might be even more confusing with that jump, but where there's a hole in here, those values are covered somewhere else in the graph. They are used. So the fact that it might not go in order, it might have a jump, does not change the fact that every y value from the lowest one, down here at -2, to the highest one of 10, everything gets used by some point, by one or more points. Nothing gets jumped over completely. So the range goes from -2, including that -2, to the highest value of 10 and includes 10. X-intercepts, I see 2 of them. One is just after 15 and one is at 21. So about 15.1 and 21. Y-intercepts, we have just the one, and it is at 10. Okay, directions are changing here. At number 2, we are told that each of these is a continuous function. Right? We would not know that without the graph unless we're told so. And there's another interval notation over here. These square brackets, 0, 6, is another way to just write everything from 0 to 6, including both endpoints, 0 and 6. I don't like to use those because it looks too similar to coordinate notation. So just think of it as this same interval notation with inequalities we've been using. So, what is the domain, range, and intercepts for the function I see in this table? So let's start one at a time. The domain. All right, our domain is everything from 0 to 6. Do we have values in between the ones shown here? The natural numbers that we see, or the whole numbers we see in that table? Yes, and we know that just because we're told it was continuous. So the domain is everything from 0 to 6. Should look familiar. The range, now the range, again, I only know that it will be an inequality, interval notation, because of this continuous. That's telling me there aren't any jumps. So the lowest value I see here is -3. The highest one is 20. Because I'm told it's continuous, everything else must get touched, used between -3 and 20. So from -3, including that -3, to 20, including the 20. The x and y intercepts. Well, an x-intercept is where the y value is 0. So that's right here. X-intercept is 2. A y-intercept is where the x value is 0. So the opposite letter is always 0 for intercepts. Well, that's this one, so that's also 2. Based on that table, identify the minimum value and where it is located. Well, we kind of already said that when we did range, but our minimum is -3, and that occurs at, or it's located at, x value of 1. Okay, so that's the point 1, -3. The minimum is -3. It happens at 1. Okay, so number 3, I don't know if this was real clear, but let's do this using only the points in the table. So not treating it as a continuous function, okay? Treat it as a discrete function. So determine the domain, range, and x and y intercepts. So domain, if it is discrete, like I'm telling you to use it, then it's just these x values I see. So I need to list them 1, 2, 3, 4, 5. I cannot write an inequality saying everything from 1 to 5 because that would include all the decimals and fractions in between those integers, and I do not want to include those. The range, again, would be just the numbers that we see. So we used a 3, a 4, a 5, an 8, and a 10. X and y intercepts. X-intercept is where y is 0. Well, notice I don't have that. It's not in the range. So none. Y-intercept would be where x is 0. Again, it's not part of the domain. X is never 0, so there is none. And then based on the table, identify the minimum and where it is located. Well, the lowest value in my range is 3, so the minimum is 3. It's located at, well, where did we have that lowest value of 3? It was attached to x equals 5. So it happens at x equals 5. And we're talking about the point 5, 3. The 3 is the minimum. It happens at 5. Now before, I had a few hints here, a couple of hints. For number 4, to describe the key features of this situation, maybe try making a graph. Okay, so the amount of daylight depending on the time of year. So if we think of this as the time of year, like the months, and then the y value, the hours of daylight, well, even when the days are short in the winter, it's not 0. You don't have 0 daylight. So let's say we start with January 1st, being our y-intercept. We have a certain amount of daylight, and as the year goes on, our days get longer until about July, and then they start to get shorter. So till we end December 31st with our days short again the way they were at the beginning of the year. So this would be increasing from, let's say, January to July, and then decreasing from July to the end of the year, the end of December. Now, there are no x-intercepts. You would never get down to having 0 hours of daylight. There is a y-intercept. I don't know what exactly that number would be, but it would stand for the hours of daylight on the shortest day of the year, the least amount of daylight hours you had at all. In part B here, if we made a little table, x, y, and our first term in a sequence is 36. Each consecutive means in a row, one following the next, is half of the previous term. So if I took this out to my second term would be 18, the next one will be 9, 4.5, 2.25, and so on. We could say this is definitely a discrete function. There would not be a term numbered 1.5. I would not use any of the numbers between 36 and 18. Therefore, when I tried to do domain and range, I would have to just list the values. Domain would be 1, 2, 3, 4, 5, and so on. This did not say that we should stop at any certain term number. The range would be values. Now, rather than increasing values, because this is a never-ending pattern, I would list them in just the order I see them here: 36, 18, 9, 4.5, 2 1/4, and so on. But there is no minimum. They would keep getting smaller and smaller. Now, they would not go below 0 or ever reach 0, but we cannot list our domain and range as intervals, because once again, we only use the numbers that we're seeing here in the pattern. Nothing between 18 and 9 was ever a Y value. Nothing between 9 and 4.5 was ever a value we used. Okay. Therefore, we can't talk about increasing or decreasing intervals. There are no intervals. There would also be no intercepts. Okay, number 5, key features. Marcus buys a $900 couch on a 6-month payment plan, 6 months. He's going to pay $50 each week. Okay, so we're starting off owing $900. If I think about a graph here, I start off owing $900. This is my debt. And since I'm making payments each week, I would want to put weeks as my X value, and this would go down $50 at a time. So after 1 week, it would be at $850. After 2 weeks, it would be at $800, and so on, eventually reaching 0. The question would be, when does that happen? When would I have my debt paid off? Well, let's see, 900 divided into $50 payments, it takes 18 payments. So it takes 18 weeks to pay off this debt. Okay, so when I get out here to 18, I owe nothing. I'm debt free. Now, this says he took it on a 6-month payment plan. 6 months times 4 weeks in each month would be 24 weeks. So we do not end up taking the entire 6-month payment plan. We have it paid off after 18 weeks. Okay, so what can we say here? We can say this is a linear pattern because there's a constant rate of change. Constant rate of change is -50. We can say that it has a y-intercept of 900 because we started off owing $900. Well, if it's linear with a constant rate of change and a y-intercept, we can write an equation. Y equals -50x plus 900, right? Our constant rate of change and our y-intercept. We can say that our domain is, I would consider this a discrete function, because even though the weeks are passing continuously, I'm only making payments once a week. So I would use whole numbers, starting with 0. 0 weeks in is when I first got my loan, but this ends at 18 weeks. My range would start with 900, 850, 800, and so on until I get to 0. No increasing or decreasing intervals. Since I do reach a debt of 0, that's going to be an x-intercept of 18. And I would think that that's pretty much our most important features here for this relationship. Part B, we have an empty 15-gallon tank. It's going to be filled at the rate of 2 gallons per minute. Now this one, it's an empty tank, but this is how many gallons of gas we can put into the tank. We know we don't need to go beyond 15 because that's all it can hold. That's its maximum capacity. It's filling at a constant rate of change of 2 gallons per minute. So it starts, no minutes filling the tank, no gas in the tank because it's empty. It goes up 2 gallons per minute till it gets to a full 15-gallon tank. Now, how long would that take? When would it reach that? Well, if it's 2 gallons every minute, 15 divided by 2 is 7.5. So this would be 7.5 minutes in, we have the full tank. This is a linear function. It has only one intercept. It's both the x and y intercept. So the x-intercept is 0, and so is the y-intercept. We could list that constant rate of change as 2. So if we have the y-intercept and we have the constant rate of change, we can make our equation y equals 2x. We can either write plus 0 or just end the equation after the 2x. This one has a domain. It starts at 0, has every amount of minutes up to 7.5. So we would say our domain is from 0, including the 0, up to and including 7.5. Our range would be from the minimum in the tank of 0 up to and including the full tank, 15 gallons. So it has a minimum of 0, it has a max of 15. The entire graph is increasing, so it has increasing interval over its entire domain, 0 to 7.5. It never decreases, so no decreasing interval. And I'm out of room, so we'll call it quits there. Number 6, we're going to graph this equation and show key features. We'll just talk about those a little. So first is we need to decide where we want to locate our x and y axes. Now this is a linear function. It doesn't have any large numbers. The slope's not large. The y-intercept isn't large. So I'll just kind of center my axes in the grid. We only care about the part of the graph when the x values are greater than 0. I guess I should have read more carefully. So I don't need any of the negative x values. I can actually put those axes over to the left a little more, off center. So my y-intercept is 4. That's one of the key features, and it will help me graph. So 1, 2, 3, 4. The constant rate of change, or the slope, is -2. So that means every time I move to the right 1 x value, I need to go down 2. So there's a point. I go to the right 1, I go down 2. Go to the right 1, go down 2. Right 1, down 2. And I could keep that going. But I've already established the pattern, so I can go ahead and draw in that line. Now, it does continue beyond my graph to the right. I do not, however, want to extend the line to the left because this said when x is greater than or equal to 0. Okay, so this is my domain. My range would be everything from from +4 and down. Again, that arrow does indicate that we continue to decrease infinitely. So it's f of x values are everything less than or equal to 4. It is a continuous function. It is always decreasing everywhere on its domain, so it decreases when x is greater than or equal to 0. It never increases. So increasing interval, none. There is a y-intercept, I already indicated, at 4. There is an x-intercept at 2. There is a maximum value of 4. There is no minimum because it continues to decrease even after we run out of space to graph here. All right. One more. This one we're going to graph is exponential. Now we know exponential graphs start low and increase incredibly quickly, or start high and decrease incredibly quickly. So we do want to keep, this one is a exponential growth, since the multiplier, the common ratio, is 3. So I need to keep my x-axis down low, and my y-axis I'll put mostly to the left here. Now, for some values, we do know that this is the common ratio. It's multiplying by 3. Since there's nothing in front of the 3, that means the y-intercept is 1. So I'm going to go ahead and make a little table of values here. The y-intercept is 1, so 0, 1. 1 is 3. When I put a 2 in there, 3 squared is 9. Put a 3 in there, I'm at 27. I'm already probably going to be off my grid. So, because when x is 4, this is already 81. I'm pretty sure there aren't 81 boxes there. So, we'll just put a few points to show the shape. 0, 1, 1, 3, 2, 9. So let's see, there's 3, 6, 9. When I go to 4, can I get to 27? Well, if that's 9, here's 12, 15, 18, 21, 24. Oh, I just made it. So this one, we sketch in and we know it gets really, really close to that x-axis, but does not touch it. Now, did we want this one? No, that domain is not for part B. So this one we can start with, it is a continuous exponential function. We already said it has a y-intercept of 1. It has no x-intercept. Remember, there's an asymptote that runs along the x-axis, which that graph gets closer and closer and closer and closer to, but it does not ever touch. So that implies also there is no minimum, because the graph continues skyward forever. There is also no maximum. The domain would be left forever and right forever, so all real numbers. The range, although it continues up forever, it will never go. It continues to decrease forever, but never below 0 or even reaching 0. So the range is all values greater, not including 0. It is increasing on its entire domain, the entire graph, so that's all real numbers. It doesn't ever decrease, so it's decreasing nowhere.